Okay, so Assalamualaikum and very good morning. So for this morning, okay, we are going to have a synchronous class. So if, for example, during class, you cannot hear me, example, and most of the time student will write that in the chat, but I'm not going to look at the chat during class. So please unmute your mic and say something lah, so that I know that there's a cut off means that you cannot hear me. Right, so open the mic ataupun mungkin mic pun saya tak dengar. So please open your video and then wave around. So at least I know there's something wrong with the connection. Okay, so this morning so everybody boleh dengar. Kalau boleh dengar, just write down in the chat. Yes, boleh dengar. Okay, I can hear you. Right, so that I know that this class is okay. Alright, you can hear me, eh? Okay. Sekejap. Okay, Assalamualaikum, very good morning. So I'm going to start the class here, our class, and wait for a while. So for today is that we are going to have 8 to 10 class, but may I know if there is any class at 10 to 11 example, so that if there's no class, then I will try to extend a few more minutes. So any class at 10? Any class at 10?
I have class, doctor.
You have class at 10, eh? Okay, so then I will only one student, class at 10. Okay, anyway, I will try to finish up, but we have also another class tomorrow, So today 8 to 10, and then tomorrow is at 10 to 11, so 1 hour. So I will try to finish chapter 5 by this week. Okay, so let's continue for chapter 5. Okay, chapter 5, we are going to continue for pneumatic and hydraulic actuation system. So for this chapter is the most interesting chapter that I would say compared to other chapters. So previous chapter is that you have gone through the instrumentation system, and for this week, starting this week, you're going to go for the actuation system. So you're going to learn about the pneumatic and hydraulic actuation system. Second one is the mechanical system, or we call it a mechanism, and third one is electric actuators. Okay, so let's start. So for the learning outcome for this chapter will be covering LO2, which is explain the working principle of mechatronic system. Means that in this chapter, pneumatic and hydraulic actuator, you will able to explain the pneumatic and hydraulic actuation system. Okay. Second one is that analyze select LO3, which is analyze selection and integration of mechatronic components. So for the case of this is okay, for example, you're given a scenario. Okay, you are an engineer, blah blah blah. So you need to develop a system which have comprised of actuation, linear, motion, and so on. You need to have a sensor. So this is where student need to incorporate what they have learned in chapter 1, 2, 3, 4, plus the actuating system to actually come up with a system where you have all of this actuator and sensor. So for the actuator system, most of it will be covering LO2 and 3. So after completing this lecture, student will be able to explain the difference between pneumatic and hydraulic system. So what's the difference between these two systems, and why is actually in under one topic or chapter. And second one is that able to explain the basic operation of pneumatic and hydraulic actuator. Okay, and third one is the application of pneumatic and hydraulic actuator in mechanical system. So let's just do a recap on what you have learned previously. Okay, so you have learned about you have by now should be up until this week 8. You have known that there are three main components in mechatronic control system. Okay, so the first one will be measurement system over here. Okay, second one will be the actuation system. And third one will be the complete system, which is the control system. Okay, so what you have learned so far was on the sensor signal conditioning and then data presentation system. Okay? And for today is that we are going to concentrate on this actuator system, which is hydraulic, pneumatic, electrical, and mechanism. So why I didn't put the mechanism inside here, because normally mechanism or mechanical actuator will be included in the actuators. Okay, it will be uh, together with the hydraulic actuator, together with the pneumatic and with the electrical. So actuator. So example, I give you a power steering system. So power steering system, the previous power steering system, they are using the power steering, which is using hydraulic actuator. But this hydraulic actuator will be combined with the mechanism, which is mechanical actuator. They have the gearing, they have the rack and pinion. So this is what we call as combination of actuators under one system. So uh, uh, power steering system have the hydraulic plus the um, mechanism. But nowadays, we are talking about power steering where we have the electrical drive system. Okay, so they actually combine with the electrical drive system, which is have the brushless DC motor. Okay, inside the car steering system. So that's why some cars, if you notice, some cars they are very light when you drive compared to previously. I have a Kanchil. Kanchil is very heavy. Okay, because it's only using maybe even no hydraulic, it's only using the mechanism only, the pinion. So because it's very light, control is very light, the body. So it's using the normal mechanism. But if you talk about the new cars, for example, like after that Saga and so on, they're using the power steerings, because you feel that it's much more easier to steer the car. And nowadays, if you see like at 70 or even Grand Livina, the Nissan Grand Livina is very light. Even you can actually steer one hand. Why? Because they are using electrical system inside the steering wheel system. So these are example of where you can actually apply these components of mechatronic system. Okay, so this is just go through. So what we are going to look at is the block diagram of actuators. So the function of actuators is to transform the output of a control system into a control action. So meaning that you know that we have an actuator. Actuator, it only give a motion. It's either a linear motion or a rotary motion. Okay, so it's either one. And how it actually give this motion is that by having an input signal to the actuator. So that's why it's going to transform the output of a control system. So control system normally they have a control signal out. For example, we are using PID. So the output from the PID is a control. We call it as a control signal. Any output from a controller, it is called a control signal. Or we say here is that the output of the control system. So it will control the action. So it's either in linear and rotary. So for this chapter is that you are going to learn about hydraulic and pneumatic. Okay. So later you will learn about the next, which is mechanism, or we call it as mechanical actuator. And lastly will be on electrical actuator. So this is just the definition. So what is actuator? So actuator system are the element of control system which are responsible for transforming the output of microcontroller or microprocessor or a control system into a control action on a machine or drive. So basically what it means that, okay, if you see an actuator, if it's standalone, if you only have a DC motor, okay, you only have a DC motor. So let's say that this DC motor is here, put under actuator here. So you will need a signal to actually make it move, rotate, or to move linearly. So you will need to have the control quantity here. So control quantity here means that the signal from the control system. Okay, means that transforming the output of the microcontroller of a microprocessor or control system into a controller action. So this point is actually called as the output of the controller. Okay, I will compare later on where is it. And this is output is where you have the action. Okay, so let's just remember this block. If you look back at this PowerPoint, yeah, okay, you have your actuator over here, right? Your actuator is over here, and then you have the output just now. The action is over here, and then you have the signal going into the actuation block. So just now it says the output of the controller. So this is what it means. You either have a control architecture over here, you have the micro C, you have whatever controller that you implement inside here. So the output of that controller is a signal to the actuator. Okay, so if the error is small, so it's going to give a small signal to actuator to move because the error is small. If the error is very large, then it will give a larger signal. So that's why your actuator will move more larger, okay, displacement. Okay, so here we go. What are actuators? So first one is the actuator are devices used to produce mechanical movement or motion in a system. So what it means is that okay, well, you know, we have example, you have a mobile robot. Okay, mobile robot, how does a mobile robot move? So you need to have a DC motor. So this is what it means to produce mechanical movement or motion in a system. So it's going to move its place either left and right depending on what type of mechanism movement that you choose. Movement, there are only two types, okay, which is the linear and rotary over here. So the input, second one is that the input is generally electrical signal, air pressure, fluid motion. Okay, so the input to the actuator. Okay, what it means that for electrical actuator, of course, the input is electrical signal. It's either voltage or sorry, is either voltage or it's either current. Okay, for electrical motor, normally it's current. The input signal is current. For voltage, is for example, a DC motor is voltage. And air pressure, where does the input air pressure come from? So air pressure is for pneumatic actuator. Okay, and for fluid motion here, over here, fluid motion, or we call it as fluid pressure. Okay, compressed fluid. So this is where we call as the hydraulic actuator. Okay, next one is that electrical signal can be low power or high power. So normal actuator, for example, DC motor, okay, you can just send a signal up to 10 volt. Okay, 0 to 10 volt, then can rotate. But for the example of linear actuator, tubular linear actuator, okay, they are using more than 3 ampere. 3 ampere, or let's say I give an example of the input is voltage. Okay, electrostatic actuator. Last time when I was doing my PhD, I was designing electrostatic actuator. So I developed the electrostatic actuator. Then the task was to actually develop the controller in the end to control the linear motion in terms of vertical and horizontal and vertical motion. So the input to this electrostatic actuator is actually high voltage. High voltage means that from 0 to 2 kilovolt. Okay, very large. So it's very dangerous when I do the experiment. So this is where safety is important when you enter any lab. That's why you need students, when they enter lab, they need to wear what? They need to wear the shoes, closed shoes, and so on. Okay, the fourth one is that in case of low power signal, additional circuit is required to drive the actuator, otherwise it can be given directly. So what it means that, for example, of a low powered signal, very small. So you have learned in the signal conditioning last time. Okay, if a signal is very low, what do you add? What do you add if a signal is very low?
Amplifier.
Amplifier, very good. So you add an amplifier. Okay, so you amplify the signal, because if it's too small, then because if you look at actuator datasheet, datasheet electrical or pneumatic, hydraulic actuator, if you download the datasheet, you will see that bunyi apa tu siapa tadi yang bercakap boleh mute-kan balik sebab ada bunyi titik-titik. Okay, anyway, if you look at the datasheet, you will kejap boleh. Kenapa bunyi? Okay lah, tak apalah. Ada noise sikit my side lah. I'm not sure if you can hear me. If you can hear the noise, ada bunyi duk 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 duk. Okay. Anyway, look back at this one. So the fourth one is that in the case of low power signal, okay, additional circuit is required to drive the actuator, otherwise it can be used. So you need to add amplifier, because if no amplifier, then the actuator cannot actually read the signal. Because if you download datasheet, normally datasheet, it will say, okay, what are the input to the actuator? It will say that, okay, between 0 to 10 volt. Okay, 0 to 10 volt. If the input set is 0.5 millivoltage, do you think the actuator can read anything, give any output? No, So that's why you need to understand the datasheet of the actuator that you buy. Fourth one, the fifth one is the actuator output can be positive, position or rate, which is in linear, in positioning, or rate, which is linear. So it can be either linear or rotary displacement or velocity. So this is normal. When we talk about actuator later on, you will see that we have two types of actuation system, which is linear type or rotary type. So actuator can be from few microns to few meters. So normally there are very wide range of actuator. So actuator, they can be in displacement. If we talk about displacement in linear or bilinear displacement, so it can be from millimeter. You can buy an actuator which can move in millimeter, or you can buy a actuator that can move up until meter or centimeter. So it's up to you. We are the user. We want to buy depending on what type of measurement that we want to measure. So this actuator, when you buy actuator, you need to make sure that what measurement, what is the range of the measurement, what of the type of sensor that you want to buy. So need to match, the actuator and the sensor need to match each other. So for example, is robot, automotive and machine. Okay, kejap you boleh dengar bunyi bising ke? I macam very noisy right now. Ada bunyi?
Tak ada.
Tak ada? Ada bunyi deg, tak ada? Your side?
No. Tak dengar
tak ada? Okay, baru senyap. Okay, dah stop kejap. Saya sambung balik. Okay, dia baru senyap. Okay, next. Okay, so actuator classification. So this is just a general one. Okay, because we are going into the actuator topic. So there are four main types. So let's look. So we look. But if you look here, we have the high powered torque. That means that the lowest will be the low powered up until high powered torque. Okay, high torque or high force actuation. So from below we have the electrical actuator. Above it we have the mechanical actuator. Next is pneumatic actuator, and lastly is hydraulic actuator. So if you see this classification is that's why if you see in lots of heavy machinery, they use hydraulic actuator, fluid, okay, which is compressed. They do not use pneumatic. They don't use electrical actuator for example crane. They don't use electrical actuator. They normally use hydraulic. That's why you normally see that large cylinder on the crane, because they are using hydraulic. Okay, so electrical actuator is lowest, and mechanical actuator actually is used with all of these three actuators. We have the hydraulic, pneumatic, and electric. But of course, mechanical actuator can be a standalone. Okay, you can use mechanical actuator without hydraulic, pneumatic, electrical. but it's not going to be high powered lah. Yeah? So there are two types of motion if you see here, which is the linear actuator. Okay, linear actuator example is solenoid, hydraulic, pneumatic. Okay, hydraulic and pneumatic can be normally will be in linear motion, and for rotary actuator will be in terms of motor. Normally motor, if you talk about motor, DC motor, AC motor is all rotary. Of course, you have a few which is in terms of linear, but when it's in linear, it will be quite expensive. Okay, so and there will be some hydraulic and pneumatic drive which is in rotary type. Okay, later on you will learn in this topic is that example is pneumatic vane and so on. So it's going to rotate, but the basic is simple. If you think about linear actuator, directly think about motor. Okay, motor, DC motor, electrical motor. And if you think about for linear actuator is that you think about hydraulic and pneumatic, the common one to use. And there are few things for electrical actuator which is used for linear motion. And for rotary type is normally will be the electrical actuator, which is DC motor, AC motor. Okay, so how do you actually select actuator? Okay, so you select the actuator is based on accuracy and resolution. So accuracy and resolution, of course, most of the actuator that we sold in the market will actually go through the quality inspection and so on. So we already have the accuracy and resolution. But resolution means that what is resolution? And I think you have learned that in chapter 1. What is resolution? And accuracy? Kau tak ingat, baca balik lah. So what does it mean by accuracy and resolution? So you need to have that in the actuator. Second one is that power required for actuator. So what are the power required? Is it you need to have, is it low powered? It's only up to 50 volt. Okay, it's very easy then. But if it needs to amplify, okay, the output, the input to the actuator, you need a very high voltage. 3 kilovolt, 4 kilovolt. So you need to have an amplifier. So when you think about that actuator, then think about, oh, okay, how do you drive the actuator? So you need amplifier. So you need to buy, when you make a setup, you need to have the actuator plus the amplifier. So you need to buy separately. Third one is that cost of actuating device. So the basic rule is for costing. Of course, when you have a high powered actuator, so it's more costly. And another thing that into consideration of the cost is the accuracy. If it's more accurate, or we call it as precise, then it's more expensive. Okay, so you need to balance lah when you buy actuator. Okay, either way, you want to buy high powered, then if you want to have the high accuracy, then it will be quite expensive. Okay, I have few students in my research lab. They are using micro motor, very small motors, just this size, this finger size. That micro motor, one motor costs 2,000 ringgit. Okay, normally DC motor you can buy like 20 ringgit. Yang ni micro motor because it's very small one. Why people buy very small motor? Okay, example, my student he's developing a robotic finger, so that motor need to be include into the finger casing lah, okay, which is 3D printed. So it need to be insert into the finger, so it need to be very small. So because it's small size, but need to have a precise motion, precise rotation, so it's quite expensive. The one costing of the micro motor is 2,000 ringgit Malaysia. So I managed to buy two lah, so it's up combined 4,000 ringgit just for two micro motor. And last is dynamic response. So you want to look at how fast does the actuator respond. Is it very slow? Slow means that it only respond after 1 minute. You give input with very slow reaction. Okay, or you want to have it a fast response. You give an input signal within 1 second, zoom, it can move. So it will actually commit effect to the costing. Means that high costing lah if you have a dynamic more fast response. Okay, so this one is the comparison between actuators property. And so you see here the x-axis is the output speed. Output speed. So it means that the highest auto speed is over here and the output torque is on the y-axis. So if you see here, the output speed, the fastest, for the actuator that give the fastest speed will be the pneumatic drive over here. Second is induction motor. Motor also can give a very high output speed. And next will be hydraulic. And in compared to the output torque means that torque is related to the force. Means that high torque, it can actually like for example a crane crane is using hydraulic. So you can see that for output torque, highest is given by hydraulic, hydraulic actuator. But even though its output torque is high, but the output speed is slow. So you do not see any crane moving very fast. It's moving, it move up very fast. Wow, the planting anyone on the crane. So it's going to move slowly. Okay, so ya Afiq, ada nak bercakap ke? You punya mic on ke? Alright, so next we go to this just a simple setup, but it's not the normal block. But I'm going to explain. So you are the user over here. So the user task is actually to programming and supervise the system. Okay, let's say that you are an engineer. So you're going to supervise the system. Okay, and you are the one who are looking at the control unit. So you have the monitoring. So you have learned in chapter 4, you have the data representation system. You have the monitoring over there. So you can see whatever is happening on the system. So you have a robotic arm over here. So robotic arm consists of the mechanical structure. So mechanical structure that we have here is linkages. Okay, linkages. Example. And of course, you have the actuator. So example, at each of this link, okay, we have the DC motor. Okay, motor to actually move the robot, okay, 6DOF robot in which direction that you want. Okay, so we have the actuator. So means that this control unit is going to control the actuator. Okay, give the input. Okay, this control unit will give signal and the actuator will move. Okay, rotate accordingly. And if this is important. Normally, actuator do not have a sensor embedded with it. If you have actuator with sensor, then it will be very expensive. Most of the time, if you buy a motor with encoder, you can actually search in internet. Try to search motor with encoder. So what does mean that that motor have an encoder? Encoder actually is the sensor. Okay, that read the displacement. So if you can find things the item with together with the sensor, then it's very good because it's easier for you. It's already embedded. Okay, but most of actuators do not have sensor with it. Like pneumatic, hydraulic, do not have any sensor. So you need to buy a sensor accordingly. Okay, so if you're measuring, for example, this robotic arm, the rotation of the arm. For example, you put the motor over here. So the motor is going to rotate this wrist. Okay, but it's just a motor over there. So you need to have a sensor. So you're going to buy the encoder, rotary encoder, and put it and actually connect it using a shaft, okay, or bearings over there. So it's going to read every time the motor is going to move. Okay, the encoder will actually read the rotation. Okay, so that is what it means. You need to combine it into one system. So normally actuator and sensor, if you look at the system, it will be together. Okay, it will be side to side with each other. Okay, so this sensor will be the one that giving the feedback to the control unit. So does the actuator move according to the reference that you want? Okay, means that user give a reference. Okay, rotation 90 degree. Okay, does the robot move to 90 degree or does it move only to 80 degrees? So this is where the sensor give the reading, the measurement. Okay, back to the control unit. Okay. So, okay, and sometimes you have an external sensor here in the environment. For example, when you are running a system in nuclear power plant, okay, you want to make sure that in the control unit, the department, okay, in the room, the control room, the temperature is low. For example, you want to control it at 20 degrees Celsius. Okay, Okay, if it detects that temperature is high, increasing to 35, 40, then this internal sensor will give reading to the control unit to make sure that it's going to give reduce the temperature, give a cooling effect in the room. So this is where sometimes we have the external sensor. Okay, for this one is the actuator functional diagram. So I think it's almost same thing what I explained. So you have the example, we take about the example of robot just now. So you have the actuator, the robot, okay, itself, which is have the few DC motor over there. So you have the load environment. So at the end of the gripper, imagine that the gripper is gripping something, so there is the load that it needs to pick up, okay. And we have the control signal. So is it the low or high? If it is low, then you have to have the amplifier, and this is where you have the signal conditioning over here. If there is noise, then you need to actually filter out the noise. Okay? So external source, energy sources, this is an example of what I mentioned about the external disturbance. Okay, let's look at now. We go to the interesting part, which is the types of actuators. So if you see here, I mentioned only three main things, three main actuator, okay, which is pneumatic actuator. Okay, normally we call it a cylinder. And then we have the hydraulic actuator, we call it as cylinder or motors, or normally cylinder juga lah. Okay, and third one is electrical actuator. So electrical actuator, we have the DC motor, AC motor, steppers motor. Sorry, salah typo error. Okay, so where is the mechanical actuator? So mechanical actuator is embedded in all these three actuators. Okay, so actually if you want to say, okay, how many types of actuator? There are actually four lah. Pneumatic, hydraulic, electrical actuator. But mechanical actuator, we don't call it as mechanical actuator, but we call it as mechanism. Okay, mechanism. So for under pneumatic and hydraulic actuator, we have two types, normal types, which is the single acting actuator and double acting actuator. So let's look at what does it mean later on. So what is hydraulic and pneumatic motor? So pneumatic power, okay, pneumatic power is air powered cylinder. Means that the input to the actuator is compressed air. Imagine that you have a bottle, then you put or you have a syringe lah, example, syringe. You put air and then you press it, then you will feel the force there. So this is what we call as compressed air. So it's either stored on the board or injected by a pump. So normally this compressed air, the air will actually be sucked in by a pump into the compressor and compress it. Okay. Third one is that produce linear motion through activation of cylinder. So means that for the pneumatic actuator, it actually can produce linear motion by activating the cylinder based on which valve. So example, you have the single acting actuator just now and the double acting actuator. So what are the principles later on I'm going to explain. Okay, and we compared to pneumatic is that we have the hydraulic. So hydraulic is actually fluidic, which is non-air powered cylinder. So it's easy. Pneumatic is actually air, compressed air, and hydraulic is compressed fluid. Compressed fluid ni doesn't mean that fluid like water. It's actually mostly oil. Uncompressed fluid most often is oil. Require a pump to generate the pressure and flow rate needed. Okay, so you need to have a pump similar to the pneumatic actuator just now. You have to have a pump to actually suck it in and compress it. And then it's more complex and difficult to beat effectively and consistently. So compared to pneumatic, hydraulic is more complex, but there are this advantage and disadvantage between these two actuators. So later on, we will look at these advantages. Okay. Okay, this is example of pneumatic actuator. So this figure over here is a whole range of pneumatic actuator. So most of it are actually double acting actuators. And why is double acting? You can see that there are two ports over here at the side here. Here one port and another port. Okay, so Okay, here one port, here is another port. So most of it have 2 ports. Because why? You want to control it, move to the motion, reciprocating motion means that control it going move left and right. And if you see here, this is example of robotic leg, and inside this leg, you can see that there are few pneumatic actuator over here. So you can see that there's one actuator over here. You have another actuator over here. And if you see here, this part, this is all mechanism, or we call it as specific is linkages. Okay, linkages means that it's you can because of these linkages is where you can actually rotate it. Okay. And in here, you can see that there are sensors embedded in this robotic leg. So you have sensor, knee joint sensors, ankle joint sensors, means that each of these sensors is, if you look here, is that this sensors is actually side by side with the actuator. Okay, this sensor, you see that this sensor is side by side with this actuator. So normally actuator and sensor is together. You cannot actually set it up. The sensor is far away from the actuator, so it's going to have a derivation over there. Okay, so let's look at what are pneumatic actuators. So it's very similar to hydraulic system, but the power, okay, but power to weight ratio is much lower than hydraulic system. So it means that hydraulic system can give a higher torque. Okay, in this sentence, because the air is compressible, it's compressed and deformed under load. Okay, so I think this is understandable. Okay, similar concept to hydraulic, accept power from compressed air. So concept, okay, later on, the concept or principle of pneumatic, when I explain it later on, it will be similar for hydraulic. Okay, the concept is same, just that the input is different. Input is for pneumatic is compressed air and hydraulic is compressed fluid. Okay, that's the difference. But basically, the principal operation of the both actuator is similar. Fast on and off type task, okay, means that you can actually move it very fast depending on what type of valve you are using. Bit force with elasticity, so means that this statement means that the actuator, both hydraulic and pneumatic actuator, is actually a non-linear system. Okay, non-linear system. What does it mean by non-linear system? If you have a graph here, this is X, this is Y. Means that if you give a voltage over here, this is voltage, then it's going to give a non-linear system like this. Okay, this is torque, for example. For hydraulic and pneumatic actuator, they are going to give a non-linear like this. But compared to, let's say, compared to DC motor normally is going to have a linear type characteristic. Okay, and sixth one is that compared to the hydraulic is that there's no leakage. There's no leakage problem. But yeah, it can leak air, but most of the time it's not going to leak, not going to actually effect to the system much compared to hydraulic. If you see hydraulic actuator, mostly we are using it in our car, hydraulic power kan, power steering semua. That's why we see macam power steering, even for the braking system, hydraulic. That's why sometimes if your hydraulic system is leaking, then you have the fluid moving going out. Then if you actually cannot apply the brakes, you cannot apply the brakes, sebab they're leaking. The fluid is going out, and you cannot actually compress the liquid anymore. So that's why sometimes you have faulty braking system. Okay, so this is the typical pneumatic system. So if you see here, okay, this is the overall system. So example later on, maybe you have the privilege to do final year project under my supervision. So my students are actually using pneumatic system for their devices. So the pneumatic system comprises of three main parts, and the first one is air preparation. So for the air preparation is that we have the compressor over here, okay, compressor, okay, where the compressor will actually pull in air into the this compressor and compress the air. It was going to filter the air, and then it's going to reduce noise. They have a silencer to reduce noise. If not, it will be very noisy inside the lab. And then Second one is that you will need to have the valve. So after the air is being filtered, okay, it's going to move into it actually going to move into the valve. So you are going to sub it into the valve. Okay, so this one is where you control the airflow. So this is where sometimes you will have sensor over here. If you see here, why this airflow is actually connected to the interface. So this one, let's say that this one is actually your PC, PC. Okay, your PC where you have the Arduino or you have the DSP board. So it's going to control everything, and most of the time it's going to control the signal given to the actuator, and second one is that signal, the reading that you get from the sensor. So this is actually a sensor that is going to read the valve. Okay, going to read what is the valve speed, okay, opening and closing, okay, from this air compressor. And from here, this air compressor, for example, you only want it, for example, 8 psi, the maximum speed that you want going into this valve. So we call this as the control valve, directional valve. So if you see here, the input to this valve is only one port, but the output is 2 port. So this 2 port, first port and second port, will actually be the one that is going to control this actuator over here. This is the actuator. Okay, so the first you go to this one port, left or right port, and second one is going to go to the left port. Okay, so this control valve is really important when you have a especially a double acting cylinder. So this is what we call as a double acting cylinder. So this is example of pneumatic actuator. So when air is given to this actuator, either left or right, depending on the signal that you control by the valve. So if you see here, these are the signal. Okay, this is signal that is controlling the valve here. Okay, and normally this valve is you have a solenoid, a small solenoid to control the opening and closing of the valve. So it's either going to open the air moving to this port or moving to this port. Okay, depending on which port is open. So which signal is given by the board. And this digital output is actually the sensor that is going to read what is the reading given by these 2 ports. So this is digital out going to the PC. So this is sensor, and this is the going into the valve. Okay, so pneumatic actuator, if you see here, these are the 2 port that I mentioned just now, 2 port, the air in, and this shaft will actually move left and right depending on what type of air that you give to the actuator. Okay, right, so we look at the first one, which is air preparation system. Okay, air preparation system. Before that, I will play the video over here. Okay, I already upload this PDF, so you can actually, in the PDF, you can click on the link. Okay, you can click on the link and play the video, but well, I'm going to show you the video here.
This video will describe how industrial pneumatic systems work. These 5...
Can you hear the video? Can you hear the sound?
Boleh.
Boleh dengar?
types of
Okay.
components.
Right, let's look at the video.
Common elements used in these systems. The ultimate goal of this entire collection of components, in most cases, is to create motion that will do some type of work in an industrial setting. Pneumatics is one of the most widely used technologies to automate repetitive processes. Some common applications might be to move product from one place to another, or to press or clamp pieces of a product together. To best understand how the system works, we will start at the beginning with the compressor and follow the process through to the end goal of motion. The compressor generates the energy that powers the system in the form of compressed air. In order to generate compressed air, the compressor draws in atmosphere from its surroundings and squeezes it or confines it into a smaller space, creating the energy needed to drive the system. Once compressed, the air needs to be dried and cleaned so that harmful particulates such as rust or dirt does not clog up the moving parts of the system. The compressed air will travel through a tube or line to the next component, called an air preparation unit, or FRL. FRL is short for filter, regulator, and lubricator, which are common pieces that make up the air preparation unit. Typically, the first unit in the air preparation system is what is called a bulk liquid separator, which circulates or spins the air using specially shaped vanes. The rapid circulation of the pressurized air sheds unwanted moisture due to centrifugal force. The next unit is a filter, which further removes particulate and moisture in a two-stage process. Just like in the bulk liquid separator, a series of vanes or louvers in the filter circulates the air in the first stage. In the second stage, the air passes through a screen of sorts, called an element, in order to catch unwanted debris. Once dried and cleaned, it is common to adjust the level of air pressure coming out of the compressor. This adjustment has an impact on how much force the system generates. Higher pressure allows the actuator to put out more force, and lower pressure creates less force. The regulator achieves this using a spring-loaded assembly. The knob on the regulator adjusts the force of the control spring to achieve a desired pressure set point. Whenever the downstream pressure level drops lower than the desired set point, the poppet, or internal valve, opens a pathway for the higher pressure upstream to flow downstream. This continues until the pressure in the system reaches the regulator's set pressure. At this point, the poppet or internal valve closes until there is a new downstream demand. It is also common to have a pressure gauge on a regulator so the user can monitor downstream pressure. Finally, in specific applications, such as air motors or pneumatic tools, a lubricator can be added to distribute a fine mist of lubricant into the compressed air to help lubricate downstream components. Now that the compressed air is clean, dry, and set to the correct pressure for the application, the next step is to direct it where to go to create motion. A directional control valve is used to achieve this task. This directional control valve has a series of internal pathways that can connect the air coming into the inlet port with one of two avenues to leave the valve, called working ports. Depending on the position of the moving element, which is typically called a spool, the air will be blocked from traveling down one pathway and allowed to travel down the other. The high spots on the spool, called lands, will block the air from proceeding down one path, while the lower sections on the spool, called grooves, will allow air to flow around them and proceed to one of the working ports. In this common type of valve, when the unit is not activated, the spool is forced to the left side of the valve by a spring. In this position, you can see that this land blocks air from going out the number 4 working port, and instead is forced to go out working port number 2, because the grooved lower section of the spool allows air to flow past it and out to the number 2 working port. In order to change the direction of the air to the number 4 working port, the valve needs to be turned on. In most automated equipment, a PLC, or programmable logic controller, will instruct the valve to shift using an electrical signal. When the signal arrives at a portion of the valve called a solenoid coil, a magnetic field is created that pulls a cylindrical piece called a plunger towards it. When that plunger is unseated, it allows air from inside the valve, known as pilot pressure, to push the spool to the right. Once the spool reaches the far right side of the valve, the lands or high spots are now closing off the passage to the number 2 working port, and instead directing the compressed air to flow to the number 4 working port. When the signal from the PLC is removed, the force generated by the electromagnet is also removed, at which point the spring on the plunger returns it to its normal state, which removes the air signal that is pushing on the spool. The spring on the opposite end will return the spool to its default position once again, directing air back out the number 2 working port. The PLC can now direct air to whichever port is needed, whenever it is needed. The next component in the system, the actuator, will allow us to do some useful work with the air we compressed, cleaned, and redirected. In most applications, the purpose of changing the direction of the compressed air with the valve is to cause motion in different directions. Parker makes a wide variety of actuators, or cylinders as they are also commonly called, that will convert compressed air into motion. The most common type of cylinder is the rodded variety displayed here. The actuator will create motion using the energy of the compressed air that is supplied to it by the directional control valve. We can see that the working port number 4 is connected to the back or cap end of the cylinder. When the compressed air pushes on the piston, it is forced to move forward inside a hollow cylinder that is commonly called the body. The piston is attached to a rod that will extend as a result of the force generated by the compressed air acting on the piston. The actuator will continue to move in that direction until it reaches its physical limit, or if the force resisting motion, commonly called the load, is higher than the force of the compressed air, in which case the pressure regulator can be adjusted to a higher pressure. Now that we have completed the extension, we will need a method to retract the actuator to its original position. The directional control valve will achieve this by changing the direction the compressed air flows from number 4 working port to the number 2 working port. The number 2 working port is connecting to the head end of the actuator, and when the compressed air pushes on the opposite side of the piston, it will reverse the direction of the piston rod assembly. This reverse motion is typically referred to as retracting. For this actuator to retract, the air that is already filling the cylinder needs to go somewhere, which is commonly referred to as exhausting. The exhaust air is illustrated by the red color and is shown exiting the cylinder and flowing back through the valve, out the muffler to the atmosphere. This system can repeat this process as often as the PLC tells it to move things from point A to point B in one example. In this example, the PLC is telling the actuator to move this product by sending a signal to the directional control valve, which is using the clean, dry, compressed energy to power the actuator. Pneumatics are also commonly used to press two components together in an assembly process to help form a finished good. Through the combination of Parker's air preparation, valve, and actuator products, there's a wide range of applications that can be solved. Visit us at parker.com to explore all of the pneumatic products we have to offer.
All right, so okay, you have listened, you have seen the video just now. So basically the video explain about each of the components. Okay, hello. Okay, the video explain each of the components. So it's explaining the air preparation system, it's explaining the valve, and explaining the actuator. So what it explained just now is the working principle of the actuation system. Okay, so okay, so I'm going to skip here. So just now, because it's already being explained, so you have the air preparation system. You have, if you see in the video just now, you have the filter to filter the air from dust and then filter it out of from moisture. So it's the air going into this valve. Okay, this tube will be a clean air. And then it will move to the control valve over here. So in the control valve just now, you see that the input to the valve is only one port and the output is 2 port. And on each of the port, you have the exhaust valve. Exhaust valve is where the air is going to go out after each direction. Okay, and this air, depending on how you control the control valve, then your actuator, your pneumatic actuator will move accordingly. Okay, so this is a little bit on air preparation just now. It's similar to what is explained in the video. So what you have here is actually starting from below is the air going into the compressor. So the air inlet to the compressor is likely to be filtered because just now you have seen that you have the dust. So it's going to be filtered via the filtering and silencer. Silencer is just to actually reduce the noise, because if there's no silencer, then the compressor will be very noisy. And next is going to go into the compressor. So to actually to compress the air, you need a motor. That's why a motor will be attached with the compressor. Okay, and after this is a pressure relief valve. The air will go into the pressure relief valve. So this will provide protection against the pressure in the system rising above the safe level. So when you have a compressed air, normally what happens when you compress something? It will be heated. Okay, air will be heated. So this is where the pressure relief valve will control what is the maximum pressure that you want it to compress. And then if more than that compressed air, then it will actually relieve. You have a exhaust valve on at this part. And this air will go to the cooler. Cooler is to cool down if the temperature of the air rises, so that the air will be cooled down. Okay. And next is going to the filter and water trap. So just now you saw that you have the after going through the compressor, cooler, and then you have moisture. Some moisture can be actually eliminated by having the filter and water trap. And lastly is that it's going to go out to the pneumatic actuator, which is to this point, the valve over here. So the air receiver is where the system, the air receiver increases the volume of air in the system and moves out any short-term pressure fluctuation. So meaning that, like it explained just now, you have the pressure gauge. Pressure gauge, the reading means that, for example, you want to have a 8 psi. So you have the gauge over here to read what is does the air reach until 8 psi. So this is where the air receiver will increase the volume of the air up until the value that you want. Okay, for example, 8 psi, 12 psi, and so on. And this air will go to the pneumatic actuator. But of course, before it's go directly to the pneumatic actuator, it's going to go into this valve first. Yeah. Okay, and third one is that, okay, this one is already explained about the actuator procedure. Okay, this one is example of the single actuation. So for single actuation, it's almost similar to the double actuation that's now in the video. So single actuation, normally you have the input to actuator is only one input valve. Compressed air is going to into the pneumatic actuator, and after the air is moved into this compartment, then this cylinder will actually move to the left side, means that move motion will be going to the left side. Okay, and normally you have a mechanical stopper just in case that is not going to extend out of the limit of the actuator. Okay, and the air inlet is where you have the air here. Okay, because you are going to compress, the air is going to go inside this pipe. Okay, so whatever air inside here is going to move out of here. So, and normally for this single acting actuator, you have a spring. Okay, over here, but this in the figure there's no spring. You can see a spring, but there's a spring where after air is going to move out, then this cylinder will actually retract back into this part, into this side. And compare, okay, this one is an example of single action cylinder. So you have the compressed air, so this one is going to move in. Okay, and this one is the example of dual direction motion. So similar to what you have seen here. So you have two port. So you have two port compressed air over here, first one, and compressed air. So for this case is that it's using the air inlet similar for exhaust valve. Okay, but the principle is the same. The principle is that when you have compressed air moving inside here, then your shaft here or your mechanism will actually pull motion. And when you insert the compressed air into this spot, then you have the push motion. So that this is where you have the dual direction motion. Okay, so this is similar to what you have seen in the video. Okay, similar lah, so I'm not going to explain, just read through, look at the figure and so on. Okay, we skip that. Okay, now we go to an example of advanced pneumatic actuator. Okay, so pneumatic actuator is the common one that you see is the one that double acting, single acting, and we have the advanced pneumatic actuator. We call it as the pneumatic muscle actuator. So this pneumatic muscle, the retraction strength of the PMM is limited by the sum total strength of individual fiber in the woven shell. So meaning that actually this PMA, pneumatic muscle actuator, is comprised of, is similar to a human muscle. It's not the actuator is not made from a mechanical part, but most of it are from fiber, means that it's going to expand like a fiber. Okay, I will show you one example of a video, and if you see here, this is one example of a PMA made by Festo. So these are a few different types of range of actuator or sizes, and this actuator are actually connected to this part. Okay, if you see here, it's connected to the hand part. So means that for each of it will actually pull the finger to actually make a motion over here. So this one is an example where you actually can set up the PMA in this motion, in this setting. So where when you have this setting is that this setting will be connected to this shaft here, bearing or joint, and then this shaft will actually rotate the robot manipulator over here. Okay, so air source is the one from the compressor, and then you have the valve, and then it will give to the MPMA the compressed air. Okay, I will show an example. Okay, this is an example of a PMA which is done in a setup in the lab. So in here is that okay, you want to use a linear actuator, okay, linear actuator to convert it into rotary actuator. So normally when you want to do that is that you need to add a mechanical linkage, or we call it as adding a mechanism. Linkages. Linkages is mechanism. And this can actually make the actuator move. The actuator basically is moving in linear motion, but we want to control the rotary motion over here. Okay, so let's look at this example in the video. Okay, so this was done in the University of Tokyo, okay, Japan. So example here, as you can see, okay, can you hear that it's very noisy? That is actually the pneumatic actuator, PMA, the sound from the PMA. So these are two PMA that is set up in this condition. So you can see that each of the PMA is reflecting and extending accordingly. Okay, so it's like a muscle, human muscle, and because of the way it's being attached to the because of the way this PMA is attached to these linkages, so it will actually pull, the wire will actually pull this encoder over here to give a rotary motion. Okay, so you can either use directly the electrical motor to actually make a rotary motion, right? But for electrical motor, you do not have high torque. Okay, no, the torque is very low. Okay, so for the case of you want high torque, it can actually pick up a higher load. Then they implement the PMA. So when you implement this to PMA, okay, this one is by adding a weight at the end effector. Okay, so adding this weight, you can see that okay, it can actually move the weight at the end effector. It's capable to actually okay, so you get the idea, yeah. So okay, so summary, pneumatic actuator advantages is that the working fluid is not working fluid, like the compressed air is the compressed well, the input is compressed air, which is cheap and does not need a reservoir. So tak perlu, it does not need a reservoir compared to hydraulic. So if hydraulic, because it's the input is actually liquid, so you need a reservoir. Reservoir ni is actually a place where you put the liquid lah. Okay. And advantage is clean because it's air, relatively fast, easy to control the force, suitable for force feedback. Just now, as you see, the need to generate there's no need to generate magnetic field. So compared to electrical motor, you need to generate magnetic field. Okay, so where this will in the case of electrical system, And lastly is the easy to handle shock load with a built-in damper. So normally you can actually build-in damper with the pneumatic actuator. So if you want high torque, then pneumatic actuator is the best option lah. Okay, compared to hydraulic. Okay. But the disadvantage is that no control on the position. Of course, if you only use the actuator itself, it's very hard to control the position. Okay, you need to embed it with a sensor to measure the position that you want. A bit noisy, especially the compressor. Just now you've seen that it's very noisy. Has too many accessories. I think most of mechatronic system have many accessories. So you need the valve. Just now, if you see, you have the control valve, you have the air filtration system, and so on. So it's many accessories. This is an example where you can apply this pneumatic actuator in robotics, bionic robotics, okay, and automation industry. Also using compressor. If you see here, is that to compress this tires. Yeah. So this one is example. I want to show to you the uniqueness of pneumatic actuator, and this one is here. I show to you one video. This one, but you can click it on your own later on. I'll give you one example so that you get excited about this topic, pneumatic actuator.
Productive, intelligent, and perfectly adapted to its environment. Nature is both efficient in its use of resources and fascinating in its variety of motion forms. Natural phenomena are also at the heart of Festo's bionic learning network.
Festo is one company that are developing pneumatic actuators.
Product innovations per year and 2,800 patents, Festo sets the pace for its 300,000 customers around the world in the field of factory and process automation in their quest for maximum productivity. Festo employees are currently researching how automated motion sequences can be made more efficient and energy conserving in future. For example, with the aid of bionics. Engineers and designers work hand in hand. They make use of what nature has optimized in millions of years of evolution and transfer these principles from nature to the technical products of the near and distant future. The Bionic Learning Network is also part of Festo's commitment to technical education and training. In cooperation with universities and research companies, Festo promotes ideas and initiatives which go beyond the company's core business of automation, and which may open up new and interesting application fields for the future. The prototypes utilize cutting-edge technology from Festo. Bird flight was the inspiration for the development of the air ray, and yet its form resembles that of a manta ray, a form which has been continually streamlined over thousands of years. Filled with helium, the extremely lightweight ballonette behaves as if it was swimming in water. The remote-controlled hybrid construction uses the so-called fin ray effect, similar to the flapping wings of the manta ray. The fin ray effect is a construction derived from the anatomy of the fish fin. It enables the air ray to make flying maneuvers similar to those of birds. The fin ray effect has also found initial practical applications in the field of automation. With the aid of Festo's bionic material gate, 7 parts can be carefully...
Okay, if you see here, this is an example of the fin ray. Inside here, they have the pneumatic muscle, PMA. So if you see this one, the fin over here is actually mechanical linkage.
sorted in a single step. A completely different drive concept has been realized with the bionic airfish. This project combines bionic refinement with an unusual drive form originally conceived for space travel. The flow-optimized structure is based on the shape of a penguin. The innovative bionic plasma undulating drive in the stubby wings simulates the mechanical wing motion of birds, but without moving parts. Flow phenomena also play a major role in valve technology. The bionic airfish serves as a prototype to examine the reduction of flow resistance with ion beams. In the case of the humanoid, the task was to transfer the biomechanics of the human musculoskeletal system to a technical construction. The key element for the realization of this aim is Festo's fluidic muscle. Already a permanent feature in production systems, the fluidic muscle is proving to be a universal tool in a surprising number of new applications. It's simply a completely new type of pneumatic drive. Its properties are similar to those of a real muscle, but it's operated with air. When the fluidic muscle is filled with air, its diameter increases and the length contracts. This enables flowing and elastic motions. The initial force of this artificial muscle is extremely high, and its dynamics resemble those of the human muscle. The humanoid can either follow pre-programmed motions or be controlled in real time via a data suit and data gloves. This means it can be
this
used
one
in
is
places
master
which
slave,
are either
They're using
inaccessible
master
or
slave.
too dangerous for humans. Eric's arm also utilizes the fluidic muscle. It attempts to simulate as closely as possible its human role model. With the aid of Eric's arm, even more complex movements will be made possible. 30 artificial muscles move the bone structure and joints, a construction not encountered in this form in the world of technology. In combination with Festo's latest piezo-proportional valves, this technology enables precise control of the construction's forces. Coordination of the muscles and valves is made possible by cutting-edge mechatronic systems and software. Eric's arm is also of great interest to the future of robotics, as it can interact almost naturally with humans.
Okay, take note, how many types of robot is inside here.
The Aerocuda is a remote-controlled, pneumatically driven fish. Its head houses the electronics and pneumatics, which control the S-shaped motion of its tail fin via two fluidic muscles. Two further muscles control the steering movement. Once again, the fin ray effect provides the necessary motion of its tail fin via two fluidic.
Okay, you see that this example, this one is actually the pneumatic muscle, PMA. So compared to the normal pneumatic actuator is very is solid, it cannot bend, But PMA is actually very flexible. So this is what the advantage of the PMA is. Of course, PMA is quite expensive compared to pneumatic muscle. We have a few in our lab as PMA.
Control the steering movement. Once again, the fin ray effect provides the necessary propulsion. A bottle housed inside the fish supplies compressed air to the artificial muscles and the air bubble. Sensors measure the depth and control the valves. The air bubble is flooded with water to make the fish dive, or with air to make it rise. Even more agile is the Aquaray, a remote-controlled fish with a water hydraulic drive unit, whose form is modeled on the manta ray. The ray is regarded as a highly skilled underwater acrobat. Its wave-like motion provides maximum thrust with a minimum of effort.
Okay, this one is not a
By
fish,
using new types of
it's a
elastic
robot,
materials and a deformable skin, it's possible to accurately emulate the swimming kinematics of the natural model. Uses in marine research applications are therefore feasible, as the Aquaray can glide through the water without disturbing the natural environment. Whether on Earth or in space, in the depths of the ocean or high in the sky, the new drives of Festo's bionic learning network are all inspired by nature. In this way, we can develop new approaches for energy-efficient products of the future. But the researchers of the bionic learning network also have another aim. They want their projects to make technology exciting for young people. For only enthusiastic young technicians and engineers can one day turn these visions into reality.
Right. So interesting, interesting video. But you can look at, I play another one example, which is interesting. Okay, this one is Festo also, octopus gripper. Okay. All right. So can just go through this slide later on and look at the video. Okay, so now we go to the hydraulic actuator. So hydraulic actuator is almost similar to the pneumatic actuator. Okay, but it's using compressed liquid. And where you can see this type of hydraulic actuator being used is in our steering drive system. Okay, for steering drive system is that the hydraulic actuator is over here. You see that this is a reservoir lah. Reservoir. The compressed liquid is actually going to insert, is going to be direct to this valve over here. Okay, this valve, and this valve will actually move this shaft either left and right. So when it moves left and right, it will actually control the steering. Okay, so how does this actuator control the valve is that the steering there, when you move it left and right, it will actually open or close the valve over here. So that is where you have the steering wheel system. Okay, let's look at what are hydraulic actuators. So we have a linear movement. Normally it's linear movement. Big forces without gear, no need gearing. Actuators are simple. It's actually similar to the pneumatic. In mobile machine, example, you can find it in a tractor, okay, very high, large cranes. Low efficiency, however, because it's high torque and normally it will compensate with the low efficiency. So it's not going to be very, we call it not accurate. Okay, but of course, there are some accurate hydraulic actuator, but it will be expensive. Because mostly for crane, you don't need to have a high accuracy to make it move. Oh, okay, the distance is 5.5 meter, 5.52 meter. No need. You actually estimation only. Okay, and it's using motor pump actuator combination with lighter than motor. So well, it's only using the motor to pump in the liquid. Okay, combination with lighter, but it's more lighter than the pneumatic. So let's look at the typical hydraulic system. So it's almost similar to pneumatic actuator. Okay, so you have the reservoir over here. Okay, reservoir where you have the liquid. Okay, this liquid is going to be pumped in by the motor at the pump. Then after filtering and so on, the compressed liquid, the liquid will actually move to accumulator. Accumulator is where you can control the level of the compressed liquid. Yeah, we have the gauge over here, and this liquid, compressed liquid, will actually move to the valve. So it's similar to what you have seen in the pneumatic actuator. You have the control valve. So this one will direct which the air, the liquid will move to the left port or to the right port. So depending on the control valve over here. So based on that, you have this is the type of double acting cylinder. So based on the principle, the same for pneumatic actuator, based on which liquid is being sent, compressed liquid is being sent to each port, then this shaft will actually move motion in reciprocal motion, left and right motion. And okay, this is example of the dual direction. So similar to pneumatic thing, I'm not going to explain this because it's similar. So we have the single actuator acting. We call it as a plunger, or we have a piston where we have the only single acting. Then you can see that for single acting, most of the time you will have a spring over here. Means that when air is when liquid compress is direct into this spot, then the plunger will move to the left, and after the compressed liquid is go out through the exhaust valve, then the spring will actually retract back to the normal condition. So, and this shows the double acting piston. So you have both two ports. So because of that, you can actually move it left to right. So other than that, you also have different types of actuator piston type. So we have the telescopic. So telescopic means that this is the original position over here, and it's actually going to extend more than it's supposed to. It means that like a telescope lah. Okay, it's going to extend upward first stage and then extend second stage over here. Okay, this is example of telescopic actuator. So where you use it is that you can using it on a truck like this. Okay, so normally it's going to be in this position only, and when it extends to the full, then it's going to be having in this position. Okay, this is a bit of the how you calculate the weight to the weight power to rate ratio. So you can for hydraulic actuator, it offers large force at low speed. Okay, this is where it's actually the pro and cons lah. You can have large forces, but it's low speed. Okay, compatible with microprocessor, you can actually program it to have to send a control signal. Tolerance of extreme hazardous environment. So this is just a very simple calculation on how to calculate for the top value. So the DA is the area of this rotary. This is an example of the rotary type actuator. So you have the D to A is the area, so T dot dr. So the equation is rho dot r dA lah. Okay, but this is not so important lah. So because in mostly in this subject we are going to cover on we are going to assess student on the basic principle and also the knowledge on it. So but you can go through it. So A is the effective area of the piston and P is the working pressure lah. Okay, dr is the radius. Okay, so this is an example of a simple hydraulic. You can see that simple hydraulic can be done using a syringe lah. Okay, you can just Google in the YouTube. Okay, example of hydraulic jack using syringe. So example, just using a simple syringe, you can actually move the load upward. This is another example of hydraulic using for underwater, remotely operated underwater vehicle. So you're using hydraulic. Okay. And then this is another, okay, other than normally hydro and pneumatic is using linear actuator, linear motion, but we have also linear actuator. So the concept is the same. We have two inlet over here. So when air is, when fluid is direct into this pot, so this pot, this air, the red one, will actually rotate this shaft to the full rotation like this. Okay. And when you have the air inlet, the fluid inlet into this pot over here, then this blue, the air, the liquid in this part will actually move the shaft to the right side. So this is where you have the rotary motion. Okay, and this one is an example of you have two pots, inlet going in and out. Okay. Okay, so advantage of hydraulic actuator is that no problem misalignment in the case of mechanical system. So it's similar to pneumatic. Okay, no problem with misalignment because it is depending on the compressed air or pressure. Okay, compact and strong, no need to have a gearbox. Of course, you can also add gearbox if you want. Okay, no wear, no rusting as everything is being lubricated constantly. Well, if you're using oil, then should be no rusting lah. Of course, with the if it's using stainless steel, if you are using normal steel, then it's going to rust. Easy to handle shock load with built-in damper. Normally you have the damper because of the liquid there. Okay, so almost similar to the pneumatic, just that it is relatively quiet operation because you don't have really need a high compressor for this hydraulic actuator. Okay, disadvantage is hazard associated with oil leakage, relative low accuracy compared to vehicle system. Okay, low accuracy because it's have a compressed liquid, and you can see that actually hydraulic actuator is used for larger equipment. Need to power pack and hosing. Okay, so you need all the tubing. Even for pneumatic, you need all the tubing, valve, and so on. So it's a bit more complex than normal electrical actuator. It is slow and expensive and need too many accessories. So similar to pneumatic, lots of accessories because you have the filtration, air filtration, or liquid filtration first, and then next you have all the valves, and then you have the actuator at the end part. So this is one example of where the hydraulic actuator is used for robotic. This is a long time ago, but you can look at here, look example. Okay, and another example is the hydraulic power steering. So if you want to look at how the hydraulic power steering is used in the hydraulic actuator is used in power steering, then you can just click the video and look at the video. Okay, and this is another example of using hydraulic actuator for high power crane. Okay, so you cannot see a crane using motor, electrical motor, or even pneumatic actuator. No, they are using hydraulic. Okay, so my question. Okay, my question. Okay, I think I left one video. Wait. I left one video on the speed. Okay, this one. Okay, pneumatic actuator. Okay, this one. How to control the speed of pneumatic actuator? Just now, you watched the video of the Festo, the robotic finger just now, the robotic, the humanoid robot. So you can see that the actuator can actually move very fast or very slow. Okay, how do you actually control the speed of the actuator? Okay, one way is that you can actually control give the specific signal to the valve. So you have the control valve over here. Okay, the valve here. So you have control valve. So specific signal is either you want to give a small signal or specific sine wave signal. Okay, so but let's see in this video how you can actually control the speed of a pneumatic actuator. Okay, let's look at the video.
Hey guys, Scott from Freight Props here, and today we are going to be talking about controlling the speed of a pneumatic cylinder. So we have a couple cylinders set up here with a couple options as far as controlling the speed. We get this question.
Okay, and then please take note, how many questions, because you're going to answer the question in the feedback form and also in the feedback form later on.
Frequently, like, how do I control how fast my cylinder moves? Can I make it go faster? Can I slow it down? And the answer is yes. And here are a couple ways you can do that. So first up, we have a standard double-acting cylinder, and this is just the standard setup. You have the elbows going into the ports here, and if we activate it, you'll see it activates at basically a standard speed. Now let's say you wanted to slow that down. You wanted the cylinder to extend more slowly or retract more slowly. To do that, you would use flow control fittings, which we have installed on the second cylinder here. As you can see, these fittings have a needle valve, a dial that you can turn in order to meter the flow of air going into the cylinder. So as you turn the needle valve and tighten up the passage of air through the fitting, the cylinder will extend and retract more slowly. Now, because these are double-acting cylinders, that basically means that air both pushes the cylinder
So,
As always,
right. So, where was the question? So the question, okay, how many methods are there to control the speed of pneumatic cylinder? Explain the pro and con of each method. So there are few methods just now, right? Okay, how many methods? Did you jot down? How many methods? Guys? Hello? Hello? Hilang lah. No sound. Oh, no sound. You tak dengar? You cannot hear me? Hello? Sekejap eh. Hi? Hello? Hi? Guys? Guys, can you hear me?
Yes,
Hello?
doctor.
Yes.
Hello? Can you hear me?
Yes.
Oh, you mean the video sound? No, there's no sound.
Yeah.
Okay. Anyway, why didn't you tell me? Okay, anyway, tak apalah. If you cannot hear the sound, then later on, go to the slide that I have upload in YouLearn. Okay, wait, I open the YouLearn. Okay. YouLearn. Sekejap where's the YouLearn? Sharing. Okay, YouLearn. Okay, YouLearn. You are in week. You are in week 8. Week 8. So click there. So in YouLearn, I have uploaded. So make sure that, okay, make sure everybody, okay, because I noticed that lots of students didn't go through the instruction that I gave. For example, every week you have the instruction of manual tick your attendance. Okay, so it means what? Click here and then go and click here, attendance. So, I mean, based on your name, so click on the attendance. This is because it's marked, it's this lecturer, so you cannot see the attendance. Anyway, okay, click on the attendance. Okay. And then class number 2 is right now, WebEx. And then you have the reflection. So make sure reflection, okay, if you move your cursor at the text here, there will be a link actually. So click lah, okay, click. If it's moved to a hand too, means that there's a link over there. So I have to upload the chapter 5. So chapter 5, you can view that video just now. Okay, go to the pneumatic, I think under pneumatic chapter, the link for that video. And then the appendix is also I give to student. Okay, this one is the like a notes that you can read through regarding the pneumatic and hydraulic actuator. Okay, so for reflection, make sure that you fill in the reflection. So, okay, answer the question. Okay, blah, 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 blah. Okay, I have asked here how many methods are there to control the speed of pneumatic. So, basically, it's based on the video just now. So, and then make sure that you submit it. Okay. Alright, so that's all. Thank you very much. We're already 9:59. So, that's all. Thank you very much. Okay, so means that because this week we already finished chapter 5. No, so tomorrow no class lah because we already capable to finish it. So make sure that fill in the feedback form. Alright, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Okay, welcome. Bye.